Great to see so many people here, or at least see a nice big number of, 35 people in the room, including myself, so 34, which is a good turnout by any stretch of the imagination. And it's good. I was actually chatting with a few people in sort of Yorkshire and so on about doing a kind of a tour of user groups early last year. And obviously with COVID, it wasn't possible. So it's great that I've had the opportunity to get back around, even if it is virtually now. But maybe with COVID almost on the way out, at least in the immediate term, maybe I'll have a chance to actually come by in person at some point in the future. It'd be great to come back to the UK at some point. So yeah, and thanks, Kevin, for organising this. Really appreciate that. I'm going to sort of just dive in. I'm going to try and keep this to about 8 o'clock UK time, so 9 o'clock European time. So maybe an hour and 20 or so, not much more than that. I just want to keep this, without everyone turning off. I know with online sort of presentations, it's that much harder to sort of keep interest, and that's just the way it is. So I guess the objective of the talk today is really not to teach you everything about F# and so on, but more just to whet your appetite, maybe dispel some myths, and give you a feel for the language, and maybe just encourage you to do a .NET new and then put --lang F# instead of not, and actually just give it a go and see what you think of it really. So let's get started really. So yeah, that's me, Isaac Abraham. Basically my background is that I've been doing C# since .NET 1.0, so I'm showing my age there. And I think that's almost an important thing just to touch on, to keep in mind with the things I'm going to say today, which is, there's a tendency I see, certainly on Twitter, to think of the F# devs as this other sort of group of people, but the truth is actually the majority of F# devs are actually long-time C# developers as well. So a lot of the things I'm going to say today, take it from the point of view of someone who is actually, someone who's used C# for many years and still really quite fond of the language and still has a keen interest in it, as opposed to someone who's maybe coming from, Haskell background or OCaml or something without that sort of rich background in .NET, which I think I've been doing for a few years now. In fact, more than F#, I'd say. As you can tell from my accent, I'm not German, but I do actually live in Germany, but come from London originally. From Tottenham. I'm the founder of CIT, so we're a consultancy. We do sort of development solutions outsourced for customers, as well as training and consultancy. Pretty much everything we do is F#. Allegedly, I think it's a Visual Studio MVP now. They keep changing titles every year or two, but I have no clue what it is now. But I still get the Azure credit, so I assume that the award is still going strong. But yeah, damn right. This was from, for any Sheffield United fans, I had to just do this very briefly. There was obviously a game the other night, yeah, that's the end of the potential jibes that I'm going to do. Nothing more than that. So I hope that's all right for any Sheffield United fans. Please be understanding. Tottenham have had an absolutely awful season this year, so any chance I have to just rub it into someone else, I'm more than happy to do. But aside from that, the real reason I'm giving this talk is the way I used to talk about this was, why am I giving this talk? Because I want to talk about F#. But in reality, I think that's really not the real reason why I'm doing that. So the way I tend to think of it these days is more about, I'm passionate about writing quality software, which I imagine most of you in this user group and this talk are also sharing with me. And as this is a .NET user group, I imagine you also are passionate. You're also passionate about writing quality software on .NET, which is also the same thing for me, except I happen to think, and from my experience, that the best way of doing that on .NET is in F#. So try not to think of this as I'm passionate about F# as a means to an end, or rather, I'm passionate about F# because I like F#, but there's no real reason behind it. It's more about my real goal is the top thing, writing quality software, and I simply think that F# is the best way of doing that. If you guys have any questions, feel free to either put them in the chat. I'll try and get the chat window open on the other side if I can manage that. Yeah, let me open that there. And you can just write in there, or to be honest, just turn on your mic and jump in if you've got any questions. I'd rather you do that than get until the end of the talk and then things have sort of, gone by 20 minutes earlier. What I'm not going to do is go through all these features in F# today. There's really no point. Two reasons why. One, there's loads of talks on YouTube of people doing that, and there's lots of docs. And to be honest, if I was to do that, it will just confuse you. There's just all these different things, and it won't really give you a flavor for F# as a whole, which is really what I'm interested in doing, rather than show you these individual features in isolation. I've done it in the past. The general feedback seems to be, yeah, this looks pretty cool, but I imagine you can't use it in the real world, which is really what I want to avoid. So there is one slide I've got here that I'm hoping will show that instead. And this is really it, which is anything I show you today, you'll hopefully enjoy and understand, but the truth is, if you really want to get F#, you have to do it for yourself. You've got to try it out. You've got to do a .NET new console -lang F# or file new project in Rider or Visual Studio. You've actually got to try it because it's actually really difficult to really grok what that special thing about F# is until you try and do it yourself. But I'm going to try and, as best as I can, to try and give that feeling anyway and demonstrate some of the things it can do. So it's more about, yeah, as I said, how F# as a developer makes me feel, and the things I like about it, as opposed to sort of these low-level features. I usually do this obviously as a face-to-face, but if you want to just type into the chat here what your background is. I mean, if you C#, if you're JavaScript, if you're TypeScript, if you're Python, whatever, just to splash that into the chat, and then I can sort of read that as I'm talking along, and maybe I'll tailor some of the talk towards the answers that I get there, really. Don't be shy. Cool. So the 3 steps I think that I'm going to do today, excuse me, will be just to look at what is and isn't functional programming in F#, try and dispel some myths, try and show you what I think really is the core of F#, maybe give you some value propositions as to why you really should be looking at it, and again, why it's really not that hard to start with it, and then look at what you could do to actually get started tomorrow. And there are quite a few ways of doing that. So yeah, I think so. So a couple of F# people in the call, which is a nice surprise, and a few C# people as well. Okay, good. JS when it can't be avoided. Yes. I'm not gonna comment on that one, but yeah. And obviously there'll be some demos. I'll try and leave maybe 5 or 10 minutes at the end for Q&A as well, but feel free to just ask throughout. So I'm going to start actually with a quick demo. So let's see if I can get this right. Tab. Where's the browser gone with all my slides in it? Oh, wonderful. There we go. Right. So let's move this onto this slide deck. So, Kevin, have I done that properly? Let's nod if you can see it. Yep, good. Okay. Cool. So this is a website I wrote some years ago, maybe 3 years ago, because for all the UK people on the call, we all know that everyone is obsessed about property prices, and the UK government actually actually expose every sale that happens in the UK I think it's on S3, and you can basically download every transaction. And I basically wanted to write an app that would let me sort of search these properties and do some sort of visualizations on it. So I did something pretty simple. So I can do sort of type in Tottenham, get some find as you type stuff. I can hit search, get some results. I get sort of faceted search on the left, which is the sort of thing you get on Amazon when you're looking for stuff, and you get sort of subcategories on the left. Table with some results. I can do sorting. Fine. I can also sort of click there. I get a little pop-up with some Google Maps. And then I can also say, right, I want to see things by postcode. So now it's going to do a property-based search based on distance. Then I can hit map, and I can see a Google map and get some details there. So, some of these things are pretty standard now in JavaScript apps and so on. So we've got sort of validation as I type. So if this is not a valid postcode, I get some type head validation and so on. And then when it is valid, I get that. So that's pretty much it for the app. That's the demo. So let me switch back. There are more demos later on, but they'll be all code focused. So that app is hosted in Azure. We're using things like blobs and tables. We're using Azure Search, App Service, and a couple of other things I can't remember even now. I'll just switch back actually and just show you. So yeah, so that we've got like a lookup of 2 million postcodes. I think I just store them in tables, and then we've got like 100,000 property sales. As you can see, it's been a while since I uploaded them, like roughly a year old, but 2 years old. But there we go. So the question I always ask, and I'm not going to actually wait for you guys to answer this, is how much is F# in that app? And I usually say 25%, 50%, 75%, 100%. And normally the answers I get is something like maybe 50%. For people that are brave, most people will think 25% sort of thing. The answer is actually 90% of that app was all in F#. There's no C# at all. It is running on ASP.NET. And on the client side, it's all React and JavaScript. There's only actually 7% JS written, and that is actually only a Webpack file. So if anyone's actually done any JavaScript before, you'll know why that's possible for a Webpack file to take up 10% of a whole app's code base, because it can get quite big. But actually the whole app otherwise was all in F#. So all the client side is F# transpiled into JS. The back end is F# on .NET Core running on top of ASP.NET Core. So that's sort of the idea to try and dispel this myth of, you can't do end-to-end web apps in F# on Azure or AWS. You definitely can, and we do for all of our customers, basically. So hopefully that's sort of the main sort of thing out of the way. Now I want to dive into, what actually is F#, value proposition behind it, and so on and so forth. So F# is basically a general purpose programming language, runs on .NET Core. You can interop with C# and VB. Those are like the three key things I say about F#. It's strongly typed, although I've worked with people that have looked at F# and thought it's a dynamic language, but it's absolutely not. It's statically typed, strongly typed. It's got a pretty powerful compiler and a very lightweight syntax. We'll come on to that bit in a bit as well, just talking about the syntax of it. And sort of the last bit that I often talk about is this notion that it's functional first. By that, what I mean is it allows you to do things in an object-oriented way if you want, but it's optimized for an FP first approach. Whereas with C# historically has been an OO language with FP things bolted on over time. F# has come from almost, I wouldn't say the other way around. It sort of started with the OO bit. It had to, because it runs on .NET, which is an OO language. But it really optimizes for a functional first approach. And that's really the crux of this talk. And you'll hear me say this many times today. F# is not necessarily better or worse than C#. What's important is whether it's a better or worse fit for the way you're trying to write code. And my personal view is probably 8 out of 10 people in this room would prefer writing in F# today. That's my personal view. But obviously, you guys have to try it for yourself. So when I talk about functional programming, people come up with these sorts of terms, lambda expressions or pattern matching, and non-nullability and composability and so on, or higher order functions and monads and things like that. To me, the only two things that are really important for functional programming today are things that you're already sort of using today or doing, but it's just a lot easier in F# if you're coming from a C# background. So the two things I would say are expressions and immutability. Now, I'll explain both of these. Expressions is a funny one because it's really not that difficult, but I think in C# it kind of blurs the line between statements and expressions, and they're almost used interchangeably, which means it's often quite difficult to know what they really are. To me, all an expression is something that has a return value, something that has a result. So a function or a method that returns something is an expression. but one that returns void, I wouldn't classify as one. If then is a statement. It's not an expression. It doesn't have a return thing, but the new switch expressions in C# do evaluate to a value, so they're expressions. And immutability is just the idea that once you create a value, you can never change it. Pretty simple. So in F# you don't really have the notion of a variable. You can do if you want to sort of go outside the box, but instead of variables, which can change over time, you have values. So you set a value, it never changes, and then you can create copies of that value with a change. So is anyone doing anything with C# 9 at the moment? Has anyone looked at records or this new init syntax sort of thing? So if any of you have done that, then that's basically what I'm talking about, but really across the whole language. So those are the only two things I'm really going to focus on today. You don't need to know really much more than that. If you sort of learn those two fundamentals, everything else naturally will just happen as a byproduct of adhering to those two rules. So in 2005, when F# was sort of first launching and getting up and running, this was the tagline that it went with. And at the time, I think it was a decent one, but I think it's sort of hurt the language over the years because people read this and they think, oh, F# is designed for solving complex problems. What's a complex problem though? Doesn't really, I keep hearing everyone says, oh, I'd love to use F#, but I don't have a problem hard enough to justify the effort of learning it. Well, of course, there's no such thing as really an easy problem or a hard problem. It's really just your perception and how much pain you're willing to endure before you look at something else. So I prefer nowadays to say F# is actually about solving simple problems with really, really simple code. Really simple code that we can compose together to make more powerful abstractions. But it's not about working with hard things only. It's about general purpose programming, web apps, data-driven apps, connecting to SQL, ETLs, console apps, all that sort of stuff. So in a nutshell, the sales pitch, for me at least, when people ask me, why do we use F#? Quicker to develop, fewer bugs, refactoring is way, way easier in F#. We just get less errors. As someone who runs a company that has a number of F# developers, it tends to lead them to be happier because they feel that they are more empowered to do the right thing. They have less fear about doing code, going live, because they think that they've got more confidence that what they've done is right. We still get bugs. There's no, I'm not going to say that every bit of code we write doesn't have issues, but it's way, way lower than what at least I used to suffer with in C#. And that's maybe says more about me than the language, just that I wasn't smart enough to really write really safe code in C#, whereas F# has a few more sort of guardrails to stop me doing the wrong thing. It also has some areas that you may not be familiar with in C#. So the idea that you can do more analytical workloads in F#, more scripts, maybe some more algorithmic style coding that F# is also quite strong at. That maybe in the past you might have had a Python team and you would have said, well, we'll do the web app in C# and then we'll hand over this bit to the Python guys or the R guys or whatever. And the last one is kind of an interesting one in that it allows us to work a bit more closely with our customers. Whereas before we may have showed them diagrams, nowadays we may actually sit with them and show them code and actually talk through, this is our domain model, does it make sense to you? And because the syntax is pretty lightweight, they can often understand exactly what we're showing without needing to translate that into another document. I'll skip those out. So I think the reason why I'm doing these talks now at the moment, the last year or two, is I think F# is particularly with .NET Core, started to really shine and really get into a great spot where the barrier to entry is lower than it's ever been. If we think back, I mean, to when I was doing C# a few years ago, like in the C# 2-3 days, this was a very typical sort of set of ways we would do things. I was using Entity Framework 4 when it first came out. And, everything was designer first. You created a database, you imported these models, and it would use T4 templates to generate code. You had file new project, everything was closed source. And that was kind of the world we lived in maybe 5 or 10 years ago. Everything has changed, I think, now, or is changing quite quickly now in .NET. We have this notion of code first rather than designer first. We don't always use now drag and drop tooling to create stuff, but it's often code first. We use the CLI now, you've got .NET CLI, .NET New. Rather than code gen, we're starting to move towards APIs that don't need us to generate reams of code. And everything basically now on .NET is pretty much open source. The interesting thing is F# was always in this right-hand side, almost by necessity, because there was no sort of entity framework F# team. There was no team doing, GUIs and drag and drop sort of integrations into Visual Studio. So the cheapest and easiest way for the community to start creating tools was doing everything on the right-hand side anyway. So it's almost like for years ago, F# was known as this kind of, they're doing things differently. In reality now, if you're using these tools on the right, you're probably going to find F# much less of a change from a tooling perspective than you might have done, say, 5 years ago. Microsoft definitely committed to F#. They get a bit of a rough ride, I think, unfairly, from some people in the community about not being committed to F#, but they basically invest more than anyone into the platform. Yes, of course, they invest more into C#, but C# is 10, 100 times bigger than F# in terms of users. That's no surprise then. But they're definitely committed to it. They've got a growing team. I think the difference is with how I used to see myself as a C# developer is that I think F# now with Microsoft is seen as a key player in the community, but they're not seen as running the community and telling the community what to do. So they're much more on an equal footing with other parties like ourselves, where we'll do some libraries, they'll do some. They're managing Visual Studio integration, but they're not telling us, they're not doing F# wrappers around ASP.NET. The community are doing that, and Microsoft are helping us as well with that. So I think it's a nice relationship, and it's working pretty well, and it's getting better and better. Any questions at this point before I sort of jump on? Otherwise, I'll just carry on. Okay, cool. So just a couple of slides on, well, probably more than a couple on dispelling this sort of fear and uncertainty and doubt about F#. And I hope this isn't meant to be a rant, but it's certainly going to be explaining some of the things that I've seen in the last few years on F# and some misunderstandings about the language. So I often hear people justify why not F#. I don't understand what benefits it offers. Totally reasonable. There's obviously a way around that, which is find out. So if you're coming to this talk, well done. That's not going to apply to you, I hope, after this. But there's so much good materials online now. You've got things like F# Fun and Profit. There's obviously the Microsoft docs. There's YouTube videos. There's like things that weren't there 5 years ago. There's now a huge number of good resources to learn more about F#, which is great. I often hear I don't have time to learn it. And I imagine many of you will say that. Totally fine as well. What I would say is reframe that from I don't have the time to simply it's not a priority. You'll always have time to do certain things, and there's only a finite amount of time in the day. So it's really about F# is not as important to learn as maybe an Azure tech or something else. And that's totally fine as well. But I think it's more important that at least acknowledge that it's about prioritization than I can't learn it. It's simply about there's other things that's more important to you. I hear this one as well. My company don't allow it. That does happen, but oftentimes with some of our customers that we've worked with, the reality was that maybe they didn't really understand what F# was, or the case being put forward wasn't being put forward in a way that the stakeholders could really appreciate. So if you're talking to a project manager and you want to get F# in the door, don't go to them and say, oh, it's really cool. Immutability is the greatest thing. That doesn't wash with someone who doesn't care about that. It may be more talking about things like it's going to save us time. It's going to save us money. It will reduce the number of bugs we have. It will improve our developer retention, things like that. So it depends on the audience you're talking to. Tooling isn't as good as C#. Absolutely true. C# is probably, though, got the best tooling of any language in the world. So I think you'll be hard pushed to find any language that doesn't really have that has as good tooling as C#. If you frame it differently though and say, how is F#'s tooling compared to other functional programming languages? You'll probably find that F# tooling is better than any of them. So, you've got Visual Studio, which is a great IDE. There's JetBrains Rider, there's VS Code. as well as sort of other ones, Vim and Emacs if you really want to. But those three are sort of the key ones. They're really solid IDs, and they have refactorings, they have all those sorts of things, unit testing, integration, and so on. So yes, not as great as C#, doesn't have resharper in Visual Studio, but JetBrains Rider does support it, and it's got some refactorings in there as well. So I think it's not as huge, it's not as large an issue as you may think it is. I don't like the syntax. Yeah, that might be the case. I would suggest, though, if you're the sort of person that really won't adopt a language, even if you acknowledge that it's maybe a better fit for the way you write code, just because it doesn't have semicolons and curly braces, yeah, maybe something else you want to think about there then. And the last one, and this is the only one that I would say there is no real answer around. I've worked with devs that really smart, way smarter than me, that just couldn't get F#. And I know where they're coming from because I needed 3 times to actually sort of grok F#. At the time, there was no real online resources. Today there is. But if you've been doing OO for years and years, and the way you think is really, you know, for loops, while loops, mutability, all that sort of thing, it may be that you just can't avoid falling into that trap of solving problems the same way. And I've worked with, like I said, really smart people that just couldn't leave that mode of thinking. So that may be you. In my experience, it's a minimal, it's in the minority though. So yeah, ready to touch on that. If anyone ever asks me now, yeah, what's the area F# is strong in? That's the answer. It's programming. If you want to write apps, that's where F# is strong at. So yeah. Some of the myths I hear are otherwise about the language, and I've probably already touched on these. It's too hard. Absolutely nonsense. Trust me, I'm really not that smart. I barely scraped through with my maths at A level. I didn't do a computer science degree. F# is not hard, but it is different from what you may know. Maths and science and complex stuff, again, totally nonsense. We're doing web apps in it. We're doing boilerplate, line of business apps. So all of that is nonsense. This is the key bit, and what I sort of touched on. It's the kind of throwing away some of the principles and preconceptions that we have about how you model software, how you model the real world, how you write software. That's the challenge really that I find many OO developers have. And ironically, some of the devs that we work with that are coming from data analyst background often find F# easier to start with, because they don't really have that preconception in the way of working. Just had a question about pandas and Deedle. Yes, I'll probably have a demo later on so that we can maybe just touch on that briefly as well. But remind me, Tony, when we get to the end if I don't go through it. So just touched on hard is not the same as different. And I just want to elaborate on that and give some examples of what I mean by that. So when I say, yeah, hard is not different, these are things I find hard, and maybe makes you think about it slightly differently. So if there's any SharePoint experts in the meetup, drop me an email. I would love to have you work with us because I cannot figure out how SharePoint works in our company. I don't know how to jump from one site to another. I can't find anything in our document libraries. Does that mean that SharePoint is really technical? No, it just means that I probably haven't learned it, or I haven't really looked into how it works. I just sort of had it with O365 and sort of struggling, bumbling along with it. Any JavaScript devs on the call, you'll probably know what I mean with this stuff. Like you got double equals, you got triple equals in JS. I still don't know really what they mean. But obviously that's yeah, another way of thinking of JS is hard to me, but for someone else, maybe it's quite easy. There's at least one German person on this call today. And for those of you that have learned German or are doing it, studying it, you'll know what I mean when I say for an English speaker, German is actually quite difficult. But if I was to walk into Germany having not learned anything and walked up to a German and said, I don't really understand German, therefore it can't be used in the real world. You know, I've been speaking English for years. German can't be a real world language. It's really confusing. It's got all these concepts that I don't really have in my language. Probably says a bit more about me than German. in some ways, it's a bit of a harsh example, but in some ways, F sharp, I would say, is a bit similar. It's different to what we know, but it's actually not difficult. And in some ways, I would say, it's actually getting simpler than many other languages today. If anyone can explain to me this .NET versioning nonsense in .NET Core, how you can jump from v226 to 227, but the SDK has gone from 22401 down to 22109. Please explain this to me, because I cannot figure this stuff out. That stuff is hard for me to understand. So that's what I mean when I say hard and different. Some of these things are difficult to understand, but we may not think of it like that. We can still use it. So a bit about C# now. And most of you on the call are C# devs, so it's worth just talking about it briefly. And then I think we'll be getting close to demo time. So first thing, as I said, I really like C#. It's got loads of features, excellent tooling, massive user base. You can get devs easily. This last point is probably quite important, this rapidly growing feature set. When I created this slide deck, I didn't realize just how rapidly C# is going to be growing now. It's like every feature, every new release is a whole bunch of groundbreaking features that are really changing the way, or could change the way, that you write code. Some people are really excited by this, others not so much. From a kind of functional perspective, if you look at the features that you've had in C#, you know, C#2, you had these kind of functions and iterators. Then you had link in C#3. Then there was a kind of a quiet period where it was, you know, dynamic and async and not much more. And then in the last few releases, we've really had some big features here. You know, tuples came in. Then you've had pattern matching, which has got progressively more powerful in the last 3 releases. You've got switch expressions. You know, records are now coming in. C#10 may even have union types. So these are all big features, many of them basically taken from functional languages, not just F#, Scala as well, and other ones, in terms of how they're used and so on. So if you're the sort of dev that is using these features, or you're excited by them, I would suggest, particularly if you're like someone who likes link, but also things like pattern matching and records, then F# would probably be a natural fit for you, because all of those features are kind of built in from the ground up, rather than being added on later on. And I'll talk about why that's important in a couple of minutes. Just the sort of point that I was touching with F# is actually not that difficult, and some other languages can be. I wanted to give an example of this C# range operator. I always ask this, and no one in the user groups that I've spoken to have ever got this one right. If I was to ask what does range 1 to 3 return, and maybe now that C#, I think 8 has been around, or 7 a bit longer, people might get this. Everyone always says either A to C, or I think B to D, I think it was. But it's actually just B and C, because it's inclusive on the start, but exclusive on the end. So it starts from 0, picks 1 and 2, but then doesn't pick 3. Hat 3 to hat 0, that one I didn't even know existed, but it actually is 3 from the end, but then exclusive. So it's actually two from the end if you start from 0 and then go at 0. And 5.5 returns absolutely nothing. Because it's starting with the 5th element, but actually it's exclusive, so you get nothing. Now, I didn't know this. Someone who does know it, though, probably finds it pretty normal. Does anyone know what this operator does? Again, probably it's more people now have been using C#7 or 8 for a while. Certainly when it came out, no one knew what this was. This is I think it's called null coalesce assignment, exactly. Yeah, Kevin. So if object keys is null, then it will set it to a new list. So it's just a shorthand for if null, then mutate it. This was a sample that came out, I think, with C#7, showing all the wonderful new features, or C#8 probably, maybe it was C#8. But you have like iasync enumerable of this, where you're getting some customers asynchronously. You're going to then asynchronously await each customer, which may be null, then switch on the customer, and then doing this tuple deconstruction and all sorts of wonderful, weird and wonderful things. If you showed this to a C# 4 or 5 developer, they would probably just say, what is that, F# sort of thing? Nowadays, obviously, it's different. We know better. We've got these things like nullable reference types and so on and so forth. So things have changed a lot in C#, but a few years ago, people would have said this is unreadable. This is one I really do like now. I love this one, actually. How do you test if a string is null or empty in C# 9? I'm willing to wait 30 seconds here or a minute. If anyone knows, what would they do today? And just write it in the chat. How would you test if a string is null or empty? Okay, good. It's one from Kevin. Is null or empty? Good. 2. Let's see how many we can get. Is null a white space? Yeah. Good. Oh, I like that one. String minus string equals 0. That's a good one. That's probably my favorite one so far. I don't think it's in this list. But here are all the ones I could come up with, mostly from a tweet I found. So string is null or empty. Well done. One person got that one. This is a nice one. It says, if the string is nullable, then it's going to return false, because it's like using the Elvis operator, I think it is. But otherwise, then compare the length is more than 0. And then you've got this one, which actually I think, Kevin, you actually put this one down. So well done with that one. Then we've got, if X is null or an empty string, and then not that whole thing. So that's kind of a match. This one I quite like. So I think this is saying null coalesce X, compare it to empty string, and then compare that against empty string. And if it's not, then it must be true. X is string and then not this. So this is using the new pattern matching syntax. And then you could use switch expressions as well. So if that string is null, then false. If it's empty string, then false. Otherwise, it's true. So there's lots of different ways of doing the same thing in C#. And I think to an extent, this is on one hand, it's good. It lets you be quite flexible and choose the way you like to write code. On the other hand, it's not particularly prescriptive. And I do worry that C# is losing its kind of identity of what is the idiomatic way of doing things in C# today? Which, like I said, on one hand, it can be good. You can choose how you want to use it. On the other hand, particularly as a junior dev, it might not be so easy. This is one I saw from a Microsoft, well-known Microsoft dev talking about and saying this was F#y style code. You've got 1, 2, 3, 4, 5, 6, 7 operators in there. I don't know what this does. And if you're wondering if this is like what F# is about, then this is totally not. So yeah, this sort of stuff is not what F# is about. It's not about this kind of operator overload hell sort of thing. Don't think that. But it's more the point that you can misuse this kind of stuff in any language, really. I'll skip some of these things out. And then the last kind of, I wouldn't say rant, but maybe think about this a bit differently when, how shall I put this? F# people have been talking about things like pattern matching and records and tuples and functions for years. Literally, since I was using F# like 5, 6 years ago now, we've all been talking about it, and it was like, yeah, that sounds interesting and cool, but it's probably not so useful in the real world. And now C# is getting all these features. So I put together these set of 4 or 5 pictures, which was like F# pattern matching, not so interested in, but switch expressions, they're the bomb sort of thing. Then we've got F# records. Now we've got C# records. F# has always been able to do functions inside functions. We've got local functions now in C#. F# always had the ability to just say use X instead of let X. In C# we have using var, same sort of thing. F# syntax was being called terse and unreadable for years. Now it's kind of hip and trendy though in C# world to say, look, we can write this code in half the space. It's now allowed to say that. Okay. Lists in F#. The only real issue I think here is that we use semicolons for separators rather than commas. To be fair, even that gets me once in a while if I have to jump back into C#. But in F# you have like list syntax, so you can just use square brackets. That's a list now. No need for return, so you don't need any of that. No need for semicolon in sort of statement ending, so that's totally fine. This is the only operator in F# that you won't know from C#. All of these ones you don't have in F# though. Like, there's just like, you don't have it. Just use normal sort of basic functions to do this sort of stuff. So again, one of the myths about F# has loads of custom operators and stuff. None of that is true. I would say C# has way more custom operators now that you have to learn, way more. So the only one that you do have in F# is this pipeline operator, which I think is now in JavaScript, or at least it's a proposal for JavaScript. And I think maybe even Scala's getting it now, maybe. So pipeline's really easy, but it's super powerful. So if you imagine we've got a function called add, which takes in 5 and 10 and gives you an answer. The pipeline, all it does is this. You can take the right-hand side argument and put it on the left. So I'll jump back again, add 5, and then we've got 10, add 5. Now this is a really simple operator. That's all it does, but it's really powerful because you can compose it beautifully. So imagine we had something like this. Have any of you written code in C# similar to this, where you've got the outgoing brackets with, you know, the inner thing first, and then we wrap that in another one. Well, in F# with the pipeline, you can invert the whole thing and just do this. So you can say 10 goes to add 5, goes to multiply by 2, goes to add 3. And now it reads as it should do. And of course, you don't have to use this just with calculators and arbitrary examples. You can do this with anything. So we could say load customer ID 10, validate them, generate them a PDF, and then email it to this address. And you can compose these arbitrarily. So it's almost like in F#, any function is an extension method. Any function can be an extension method. You don't have to write that crazy sort of put it in a static class and this keyword. You can just arbitrarily pipe these things together. As long as the output of one function is the same as the input type of the next one, then you can pipe them together. So you can write really nice DSLs very quickly. Okay. Just going to jump on to talking a bit about OO and FP, and then we'll probably, I think then that's pretty much it for the sort of the slidey bits. So this slide deck, I always use this slide. It basically just tries to compare and contrast the different ways you'll write code. So, and I've not said F# and C# here. This is more about the ways you write code in C# today as well. So statement oriented, most people are doing this in C#, but if you like writing code that has small functions and small methods in them that have return types, you're almost leaning towards this expression style. If you're using LINQ, you're almost certainly someone who would prefer this style of coding. If you like records, or you're trying to use them, or you have been in the past, then immutability seems to be where you're leaning towards. Stateful classes with methods, this is one that I think many devs find difficult to leave behind, but in FP, you tend to separate them. So you'll have normally a static class maybe, or a DTO, and then a class that takes in a DTO and does something with it. Yeah, declarative, pure functions, and this one is, again, if you're using inheritance, you're using, you know, template pattern, things like that, or are you someone in the C# world that prefers strategy, and someone that prefers writing small functions or methods that can be composed together. Just a question in the chat then about how does that work with breakpoints and debugging in terms of pipelines? So you can put a breakpoint within any of those functions and it will jump into that, but you can't put a breakpoint on the pipeline itself, at least not at the moment in Visual Studio. I think Phil Carter on the F# team is looking at that one. In reality, it's generally not a huge issue, partly because you can debug the inner functions that get called. And the other half is, while you still do need debugging, it's much less important in F#. You tend to spend more time writing code and it just works. Not always the case, but there's much less of a reliance on breakpoints and debugging than in C#, in my experience. Without explicit return, can you early return out of a function? The answer, Andrew, is no, you can't. F# doesn't support early return because everything is an expression, and therefore everything composes up naturally. So every branch will return the same thing, and everything must return at the same time. And we'll come to that, and there's a whole bunch of other things that F# doesn't allow you to do, just like that, which I'll talk about in a minute. So I've been just talking about C# though, and all these things it's getting, records, it's got now DUs may be coming in C# 10, maybe. You've got switch expressions, tuples, nullable references. So why not just wait until C# gets everything from F#? What's the point of actually moving over to F#? Why would I want to spend that time and energy and money doing that? And the answer is really, if you look at how C# has evolved, and this goes back to that slide I showed with the timeline, it wasn't designed from scratch to work the way it does today. And because there's no breaking changes, every feature that is added to the language has to be added in such a way that it fits in with the existing features, the existing style, and so on and so forth. And even that, as we're seeing in the chat, it's not easy to do that. So I almost think of C# as more of like a recipe with different ingredients thrown in, and then it's put in the oven, and you get this thing called C# at the end that comes out of the oven. The problem is that you can't add one feature and expect it to be, every feature works against another feature, or many features do. And you'll start to observe this if you work with other languages. If you're doing JavaScript today or TypeScript, and you like some features in those languages, you could probably see, yeah, they'd be cool to jump into C#, but you'd probably think, how could we do them in C#? Because it just wouldn't be compatible. So features like F# has with pipelines, that would be cool to bring into C#. I know a lot of people have asked for this, but if you want that, you basically need something called curried functions. And if you've got curried functions, you can't really have overloads. You can't really have cyclic references and all sorts of other things that kind of work against the other features. The same with type inference. Like if I ask you what is type inference, everyone will say var. But in F#, sort of var is like a really cut down version of type inference. But that's because it doesn't have certain other things that C# has that work against these features on the right-hand side. So there's kind of a balance to be had, and it's not the case that you can just chuck every feature into a language and it will just work. The same way that you couldn't just make a recipe by saying, oh, I love beetroot, and I love ham, and I love custard. Well, let's put them all together into one recipe, and that will be like the Uber meal. It doesn't quite work that way. And it's the same with language features. You just can't do it. So F# has a different approach. It's got almost two halves to the language. You've got the OO side and the FP side. And you can sort of interact between the two of them, but they tend to have quite a clear separation. And if you stick to just the FP side of things, then all sorts of nice sort of light bulbs turn on, and things that you just can't do in an OO world. But if you want to do that, you can, but then you would lose the ability to have like the really nice type inference or curried functions and so on. So it's a different approach to C#, where F# has started from scratch as a language designed for functional programming. C# started from scratch as a language designed for OO, and they've added on FP features as best as they can into the language. And Jared and Mads have done a great job. Really impressed with how they've done stuff like the nullable reference types and things like that. But there are always compromises you have to make along the way if you're adding things in without breaking changes. So I mentioned before some things like early return that you can't do. There are loads of things that F# doesn't really let you do. So there is no implicit conversions. You can't go from a float to an int, or an int to a float, just by copying the two across, or a non-nullable type to a nullable reference type. F# doesn't allow that. Everything is explicit. And at first this feels like a real pain, but actually it makes everything a lot clearer. And because of the lightweight syntax, it's really not a pain at all. You can't do cyclical references because everything in F# must be declared before you use it, everything. So you can never write spaghetti code. Literally, the language doesn't support that feature, if you will. There's no implicit expressions, there's no void. Everything is an expression in F#, so you can't return nothing. Even if you want to return nothing, there's basically an object called unit, which is an object that represents void. There is inheritance, I should say, but no one does it, or very, very rarely. There are no open type hierarchies. So if you want to do the equivalent of inheritance in F#, you have to know in advance what the inherited types are. And there are reasons why that is. You can't easily create an object and leave half of it uninitialized. You have to initialize every field when you create an object up front. Now, if you're used to doing C# where you can just leave fields, you know, and I'll just create this one now and I'll create half of it later on. This is really a pain to start with, but it removes huge class of bugs because you can't just have half an object and then get a null ref. That doesn't support it. And again, everything is immutable. So I'm just going to check what time it is. Okay, good. So we've still got half an hour. Okay, so I'll skip through some of these. This is basically the same slide as I just touched on. You can pause the YouTube video and read through it, but it's basically the same thing. I already just started talking about this a minute ago, but F# changes, I think, how we look at our relationship with the compiler. In C#, I always saw the compiler as someone that just got in the way and stopped me. Whereas with F#, I started to treat it as a friend of mine, someone that would help me do the right thing and tell me when I was doing something stupid as quickly as possible. You tend not to have this kind of classes with everything merged together. You end up separating them out and saying, I've got a DTO here. Here's some bit of data. I want to chuck it through my system. Here's some code that's going to operate on that DTO and transform it into something else. The middle one is an interesting one in that you tend not to start looking at things from the top-down approach, but tends to be more of a bottom-up approach. You write a bit of code to do one thing and a really simple thing, and then you trust the ability to compose it into something more powerful later on, rather than starting at the top and thinking, oh, do I need to use strategy or should I use template? And what should be a decorator here and there? You tend not to look at it like that. It's just write some simple bits of code and then plug them together later on. I already touched on this, so I won't mention that again. I'm going to skip out a couple of these bits. I sort of touched on expressions before. This is probably a good, this is the one code focused demo I'll do here though in slides. So this is some C# code. It's probably C#6 maybe. There are 3 deliberate bugs in this code, or I think 2 or 3 at least. Can anyone see what they are? So it's basically, this is a function, takes in an age. If your age is less than 18, it's going to set the description to another name. Otherwise, it's going to set it to adult. And then we're going to write out, you know, hello, you are a child or an adult, and so on. And feel free just to unmute yourself if you can see any of them. I'll give it a few seconds and then, yep. So first one was no else, absolutely right. So if you passed in an age 65 or over, then you're not going to have any branch, and therefore the description would just be nothing. So you are a nothing. So obviously not great. There's, I think, 1 or 2 more here. So the other one is here. I've given it the wrong name. So I'd actually assigned it to, yep. So I've given it to greeting instead of age description. So that's wrong. And hadn't done the else. So not great. You can fix it if you put this whole thing into a function or a method. So if instead of what we had here, where we had the if as a statement here, if you move that block into a method, you fix it because the compiler now knows that you have to return a string. So if you left that branch out, you'll get a compiler error. You can't assign it to half here and there because it's all happening atomically. So kind of all of these issues go away by moving to an expression where we're saying we're taking something and we return something. In F#, this is how everything is written. So if then is actually an expression in F#. It's not if age is less than 18, then assign the value to this thing, it's this whole block here has to return the same things on each branch. And the result of that is assigned to age description. So if you're the sort of dev that sees this and says, oh, I don't want to write code like this where I risk misassigning them and I'll do it as a method, then F# is right up your alley, because that's exactly how everything works in the language. Everything has a result. The same thing, we had switch case, you know, in the old days where you'd assign things to output and so on. And now in switch expressions, this is now the syntax where you put the output once and then you switch over them to get the result. That's exactly how pattern matching works in F#. So you'd say match the number with, and then this is the result of that, and that expression gets assigned to answer. So same thing. So if you're looking at switch expressions and you're saying, I like that, that's the default way of working in F#. It's exactly the same, except it's a bit more powerful in F#. But you know. I was listening to Kevin talk about async and await at the start of this call, just before everyone came on. If you've ever done this, C# quite nice here. If you're in an async block, or an async method, I should say, and you call another one that's returning a task and you forget to await it, you'll get this warning. Because this call is not awaited, execution of the current method continues, blah, 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 blah. It's basically saying you've not awaited this. You should await this call. Yeah, that's pretty nice. The compiler is helping us there. The problem is it only works for async await. Here's a method that's returning a string. The compiler is not saying anything here. I've called this method that returns a string, but it's getting thrown away and ignored implicitly. In the world of F#, that doesn't make sense. Everything is called and should have a result. So if you try and do this in F#, you'll actually get a warning. If I call getString, you'll get a warning that says, this has a type string. The result of this method is string, and it's implicitly ignored. You're not doing anything with it. Please do something with this. And if you don't want to, you've got a function built in called ignore that says, I don't want to use this. I know I don't want to use this. Just ignore this, the result here. So this is very different to the world of C# where you can just willy-nilly throw things away. In F#, it's much more explicit about this. Same thing for void. There is no void in F#. So if we call console write line, you'll see that the result of this is not void, but it's this thing called unit, which is an object. And unit can even be assigned to a value. So you can even actually assign it something. So there is no notion of like task and task of t. In F#, everything is task of t. And if it's not got a result, it'd be task of unit. And there's actually a few libraries in the C# ecosystem that have defined their own unit type because they want this, because they know it's actually quite useful. I'm going to skip a few more slides now. We'll skip the null stuff. Yeah. What time is it? Let's have a look if we've got time. I don't want to go too long over. We've got 20 minutes left, let's say. Let's do this one. Let's do this and then we'll jump into some coding. So I usually ask about this, like, how could you model this today? We've got a customer, and I want to model a customer that can be contacted by email, post, or telephone. But you can only have one at any time. So it can't be all three. It can only be one. But each of them allow you to contact effectively, you know, contact by email, by post, or telephone. So how would you do this in C# today? This is something I see often, is just put everything on the customer. So I'll have a telephone, and then we'll have the address bits, and then we'll have an email address. And, you know, just do things the right way. If you've set telephone, make sure you don't set address line 1 and 2 and so on. Just do one. And if you want to check, you know, I've got a method on my customer that checks if the telephone number is not null, then I'll use the telephone number. If it's null, then I'll check the address. And if that's not, and if that's null, then it must be the email address. Would anyone use this kind of approach? It's not wrong. I see this all the time. Interested if anyone would actually use that sort of thing. But yeah, that's sort of one way I see very common approach. Then I might see people say, oh, I know what, we'll add an enum in. So I'll have a contact method on the customer, And then that will specify which one it is. And then make sure if you set the contact method to telephone, that you set the appropriate field, and if you do it wrong, then, bad boy, you shouldn't have done that, Isaac. Or maybe you'll break up this thing into 3 different objects, a telephone and an address and an email. Still fundamentally the same thing, basically, got the enum and then the 3 objects. And then you're going to say, right, I'm going to switch on the contact method. And if it's telephone, then I'll do this. If it's the other one. Right. The proper way to do this in the OO world is to use inheritance and polymorphism. So you create a contact method base class, and then you're going to inherit from it with telephone or address or email. And then all have a method called contact, which is abstract, and then you override it on each one of these subclasses, sort of thing. Would anyone actually do this today? I'm genuinely interested if you would use inheritance for this sort of solution or challenge, or if you'd use one of the other methods or something else. Right. So someone's already said no straight away. I'm assuming most people wouldn't use the polymorphism sort of style approach. A few people probably will, but most people tend not to because it feels heavyweight and so on. But this is what OO is about, really. I'll do it in. I'll do the equivalent in C# in F# now, and then I'll leave 5 minutes for the end, or 10 minutes to just show a bit of web dev as well. So let's jump into some code. So let me fire up VS Code. Let's jump into CD code, and then I'll make it. Is that font big enough, Kev, or anyone? Readable? Okay. So one of the things F# gives us that's quite nice is scripts and REPL. So with this, I can basically, rather than having a console app start to explore and to work with something, I can just write arbitrary bits of code, explore it, try it out, and see what it looks like. So I'm going to leave that slide open on the other side just to remind me what I was actually supposed to be doing. So it was a customer. Let's just have a look. So we had a customer that had 3 ways of getting contacted. So I'm going to say contact method equals either telephone or address or email. So it's almost like an enum there. And telephone has a number, telephone number, which I'm going to say is a string. So think of this as like an enum, but you can attach data to each case. And I'm going to say address had line 1, which was a string, and line 2, which was also a string, and a postcode, which was also a string. And this syntax in F# is like an anonymous record. So think of this as like an anonymous type in C#, where I don't have to formally declare the name of it. And then let's call that address string. And now I'm going to make a customer, which is a record, and I'm going to say they've got a name. And they've also got a contact method, which is of type contact method. Okay. So this is a record, and this is a union type. And I'm just going to sort of compile them. So I've opened up, I've hit Alt-Enter, and that's sent it to the REPL at the bottom of the screen, where I can sort of just experiment and try things out. So I could create an email if I wanted to. So Isaac@compositionalit. And then I've got it there at the bottom. So I can start to actually create data, try it out, and explore step by step. So I'm going to create a customer. Let's say Isaac. Name equals Isaac. And you'll see here, if I now just stop at this point, I get an error. No assignment given for the field contact method. So you can't create half a record here. You have to create both fields. The compiler knows it's of type customer because that's the only type in the current scope that has a field called name. So it must be a customer. If I want, I can be explicit and put it like that, but don't really have to. And let's say the contact method was the email. So there's my customer. Great. And this record is just like a normal class. I get sort of IntelliSense and I can dot into them and so on and so forth. And it's just a normal string. So I can do the usual sort of, to string and all the usual sort of .NET methods. So nothing different there. Let's write our contact method. So in F#, rather than putting contact on the class, we have a separate method for that, which is going to take in a customer. So contact's the method name, customer is the input argument. And I'm going to say match customer.contact method with, and now I'm going to say, and you can see now the compiler has already realized customer is of type customer because I touched contact method, and that's the only type that has a field called contact method. So the compiler's worked that out for us. And I want to do a match on all of the three types. So I'm going to say email, which has an address, and I'm going to say printfn emailing address. And then I'll say a telephone number, printfn ringing number, address, posting to address dot line 1, line 2 postcode. Now the nice thing here is if I turn off telephone, just comment that line out, I immediately get a warning from the compiler. You didn't handle telephone, it's telling me. So the compiler is actually forcing me to deal with all the different cases up front, rather than forget about it, don't handle it, and maybe you get you end up with a null record in the database. So much earlier in the pipeline am I finding out that I've not done the right thing. And if I want to test it, I can just try it here. So let's say Isaac, let's say contact Isaac. I could put brackets in like this, but you don't need to in F#, so I can just say that. And there you can see emailing Isaac at compositionalit.com. The other thing I haven't really explained here so far is if I try and dot into the contact method, I don't get anything. I don't see any of the fields like number or line 1 or postcode. The only way I can get to them is by pattern matching and safely unwrapping the type. So inside the email part, I can't get to the telephone number fields or the address fields. And inside telephone number, I can't get to the email. So it's impossible for me to accidentally get to half of the object and leave the other ones blank, as we saw in the C# example. Even better, if I was to then sort of, if they had similar properties, could you get to them? Yes, so what you could do in that case is you could put at the top level on the record, we could have some shared thing. So I could put there, for example, country. So yeah, so if they all had name, that's where you would use a record for. So I'm sharing the name across all types of customers, but the contact method part is the unique bit. And that's the bit I want to specify that they all have to be different. Does that sort of answer the question, Kev? Cool. The way to think of this is if you've got like an or case, this or this or this, then you would use a union. If it's and, then you use a record. Name and contact method, whereas it's telephone or address or email. And these two types you can basically do everything with, like you can model basically everything. And this is the bit that the C# doesn't really have except for polymorphism. But if you do polymorphism, you don't get this nice sort of, you've not handled this case. And with pattern matching, you can go even further. So I can put things like, if I want to email a special case just for myself, Isaac at compositionalit.com. And then I'm going to leave this out, and then I'm going to get a warning. The value email A is a case that you've not covered. So the compiler will go through all the different types of permutations for me, and this will nest indefinitely down. So if I wanted to say, for example, let's have a contact country code for telephone. Country code is either, let's say, UK or DE or other of code, which is a string. And then I want the telephone number to be a telephone number and a country code. So yeah, you're right, Kevin. You will get warnings. The thing you won't get with in C# is it won't tell you which cases you've missed, because anyone can add on to anything. Whereas with a union type, at the compile time, the compiler knows every combination. Whereas with polymorphism, anyone can inherit, even if it's internal, it can be done at any time. So that's probably the real difference. And you'll see if you do a pattern match on a polymorph, on a base class, the compiler will just tell you you've not got a catch-all, but it won't tell you which ones you've missed out because it can't know. So yeah, I've here said I want a tuple of a country code and a string. So if I now say, let's do UK like that, and here I could say DE. And then, I've still got a compiler error here that I haven't handled the case of other, so a different country. So again, the compiler's now understood, well, you haven't handled telephone of other, whatever that is. So you can sort of nest these types as much as you want, and the compiler will help you understand where you've missed out bits or not. Right, I'm just going to jump very quickly back to the slide deck, and then I'll do one more demo of like some web stuff, and then we'll be nearly done. So let's just jump back over here. So showed you this already, don't need to do it again. You can do this in C# with pattern matching, pretty much what you said, Kevin. So if you had 3 types that you would inherit from, you can match on them using switch case or switch expression. The thing that you can't do here is you can't know that you've handled all the cases. So you can make 3 types of contact method and then you could switch on it, but you'd probably still have to put an underscore to get rid of the warning, I think. Right, last demo then. So this is literally hot off the press. So today, David Fowler was basically showing what you can do potentially in C#10 with ASP.NET 6. So what this is really showing, I don't know if that's too small, but it's showing how he potentially what ASP.NET Core might look like in .NET 6. So you've got this app that you want to run, which is this web application.create. And instead of having sort of attributes on top of methods and stuff, you basically say, I want to map a get with this route to this function. And I want to map this route for get to this function, and so on and so forth. And yeah, it looks pretty functional. And any F# dev, if you're on the call, will see how similar this looks to things like Giraffe. So I want to show you some of the libraries. And if you're looking at this, I'll actually just jump over very quickly to these slides, to the responses I saw on Twitter. So incredible, so clean and beautiful. And I'm not denying this. Replace this mutable blah, blah, blah with a pipeline, and it's nice and functional. Looks promising, love the clean and simple approach. Python with braces, I quite like that one. And then, and yeah, here's the code. So what I wanted to try and do is just give you a flavor of what this would look like in F# today. And I'm literally going to start a brand new app, and I'll try and get this going. And just to show you that you can do this in Visual Studio, I'd be more than, I'll do it in code again. But trust me when I say you can easily do this in Visual Studio as well. So I'm just going to quit the REPL. I'm going to do a normal console app at this point now. So I'm going to jump in here. I'm going to say .NET new console. And because I'm always using F#, it defaults to F# for me. You just set an environment variable and life is good. So I've said .NET new console, and I've got this console app, which has got a couple of functions in it and so on. I don't really need them though. So I'm going to just delete them all. And I've got a console app. The first thing I'm going to do is add a package called Saturn, which is a wrapper on top of ASP.NET. You'll notice I'm just using normal NuGet here. So .NET add package, Saturn, just works fine. Package reference, so all good. And I'll leave it at that for now. And I'm going to say open Saturn. Come on. Hallution. Let's do a .NET restore, just in case. Shouldn't really need to do that. Hello. Should be okay now. Yeah. So I've opened Saturn and I've opened Giraffe, which are two namespaces, and I'm going to create an ASP.NET Web App. So I'm going to say app equals application. And then I'm going to say use router. And the roots are just going to say hello world. So that's my whole app. And then I'm going to run my ASP.NET app using run app. I'm just going to lock this into a watch run cycle on the bottom so you can see what's happening. And then I'm going to use this nice extension for VS Code, which lets you just send arbitrary REST requests. So send request. And there you can see we've got back hello world. Behind the scenes, this is basically creating an ASP.NET Web App with the usual sorts of lovely stuff you have to do, but it's just wrapping that all up for us in a nice API. I'm going to actually now try and do a bit more than this. I'll say David's app equals that. Now this guy here is basically a little composable function that says, give me a string, and I'm going to return back a response, which is text. And there's also, this is just a function, and you've got other functions inside Saturn and Giraffe, so I could say XML, and now I've got XML back instead. And I could do one for JSON, and so on and so forth, but they're all just really simple little functions that you can compose together however you want. So the original one was saying, let's see what it was looking like. It was saying, let's put this up here. So I wanted to do a get for to-dos that was going to return me some data. Okay. So in the interest of time, I'll show you one I prepared earlier, but I'll just create a fake data access. Fake data equals, in fact, let's just leave that for now. Let's just get the routing working. So I want to say if someone calls get, then I want to return the text hello world. So this is now only working for get requests. If someone was to send a post through, I wouldn't get anything back. Just to prove that, I'll say send a request to get hello world. If I change this to post and save, then when I do a get here, I'll get nothing back. 404 not found. And this guy here is just like a compose operator in Giraffe that says, if it's post, then do this. And you can chain these indefinitely. So I want to go back to get. And then the next thing we had to do was to say /todos. So let's do that. So if the root is to-dos, then give back that text. Now we get that back, but if I then change this, I'll get nothing back. And each of these are tiny little functions, and you can compose them together however you want. So there's another one here that I can do, which would be for to-do /id. So I can say %i. That says ID. So what this is saying is create a function, a lambda that takes in an integer, which is what I've said this needs to be, and then return back the string as text. And this one, choose is basically saying go through all of these items here until you find one that matches. And if none match, then return back 404. So just simple abstractions that you can start to actually build up quite complicated roots and sort of features with them. So now I get back hello world 12. And if I want to give back JSON, that's easily possible. So I'm using that anonymous record again. So I'll say customer ID equals I, name equals Isaac. I've got some JSON back. Now, if we want to go one step further and really go pro, we can change this to use the Saturn extension, which makes things even more sort of readable and pleasurable, I think. So I can say get to do gives back this, and F this gives back that. So now we've got rid of the sort of the pipes and the chains, and we've made this kind of block called a router. Get this returns that, get this returns that. I can make it into a proper function if I want, so I could take this one out, put it into another module somewhere else in the app. So module, helpers, or whatever. And then let's make a function called get to do by ID, which takes in an ID. And then I can simply pass that function in arbitrarily. So I can say here helpers dot get to do by ID. So I'm just moving from a lambda into a proper function here. In F#, functions are just values. You can chuck them around. You can do what you want with them. So yeah. And just to show you that you can sort of do this as a fully featured app, let's just jump to this one here. You can see I've actually created a bigger one where I've got all of the different routes here. So I've got to-dos, put that into a module, which is like a static class you can think of. I'm going to the database. There's a nice sort of code-generated data access we've got for a real database. Just a couple of little things, and I'll put this online, this repo, so you can have a look through it in your own time. Let's just look again at the screenshot of David. So the interesting thing was here, he had like a find async. So if the customer exists, if the to-do exists, then give it as an OK, otherwise not found. We have the same sort of notion in F#. So let's jump here. Yeah. Where here I said, right, try and find a to-do by an ID, go to the database. If I got back some to-do, then I'm going to give it back as JSON. If I didn't get back something, didn't exist in the database, then return not found, no such to-do, which would give me a 404. And that kind of matching is extremely common in F#, this notion of sort of match on a result. If it's this, then do this. If it's that, then do something else. But I'll put that online so you can see later on. I'll just show you one final demo. And this is probably the one that is more interesting than anything. So end to end. So this is using this tech called SafeStack that we've been working on for a couple of years now, which is basically a full stack web app in F#. Basically similar to the house price demo I showed you before. It's kind of a mixture of using ASP.NET Core on the back end and using JavaScript and React on the front end, but everything is in F#. So yes, thank you. Let's just stop that guy. Probably have to stop this one. Let's try that again. Have I got a console? Come on, VS Code. Let's just stop and start that. There we go, right. So I'm just going to start this app up. While it's doing that, I'll just show you. So on the server, it's basically what I just showed you, using the Saturn sort of loop application with some other bits and pieces here, some other libraries for getting data and so on. On the client, it's probably a bit more interesting. If I go to index, everything is F# here. Even the view is generated in F#. So we're creating divs and A's, hrefs, setting attributes, setting children, all in F#, but it's all strongly typed. So, you know, you can't, I can dot into these things and get all the different controls that are available, which is quite nice. It's all fully immutable. So there is no sort of mutable data. It's using React and Redux behind the scenes.
Okay.
So if you've done that, sorry.
Das ist irgendwie umgestellt, er hat gerade sein Programm angemacht.
Sorry? Someone say something there, was that just me? Okay. All right, let's see if I can get this to open up now. Good. So you'll see in the back here, we've got like package JSON. So this is just standard, NPM libraries, all the stuff that you probably know and hate in the JavaScript world. There's a Webpack file here, all of that stuff. But on top of that, we've got this sort of F# facade on top. So I'll do a quick side-by-side. So localhost, let's just wait until it's compiled. I think Webpack is still doing its thing. There we go. Right, I think we're okay now. Let's see if that's working. Bundling. The good thing is I can blame this on Webpack rather than F# for it taking this long. Wait until bundle finished. There we go, right. So this is a really basic to-do app. Create your safe app and so on, and I can test, add on to it. The nice thing is this is taking full use of like the JavaScript ecosystem. So I can do things here like go onto this button and I can say things like I think it's info, and hopefully that will then change to blue. This is all like, as I'm typing, this is doing hot reload. So what do you need to do? That's now changing this guy here. So this is all using F#, but it's getting transpiled into JavaScript as I'm typing, using hot module reloading in a hot module replacement with Webpack. You could use it with a parcel as well, but it's just pure F#. There's no sort of JavaScript needed. You can still sort of go down to the low level and sort of hit JavaScript if you really want to. Personally, I don't ever want to do that though. I much prefer working in the strong typing and rich environment of F# personally. But that's me. I've never been a JavaScript dev, so if you are, then you might see that differently. But yeah, right. I think let me just see if there's any questions on this wild stuff I've been showing. Yeah, someone said it reminds of Kotlin. Yeah, that wouldn't surprise me. There's definitely some sort of, there is an overlap there. And probably where C# is going is probably going to look more like that in the future, I suspect. So I would say for me anyway, some of the things I like about F# are these things of like expressions, immutability, the union types I showed you for like the contact method. The REPL, which you saw very briefly there when I was in a script and just exploring. Type inference, the really lightweight syntax. I don't think it's really unreadable personally, but that's my opinion. Community-led, open source, but still commercially backed. So we do commercial training, we do support for F# companies. Microsoft obviously are big backers of F#. Huge ecosystem, .NET Core, ASP.NET Core, high performance. F# gets all of these things for free. So it's not a C# only thing, but yet we can ride that wave with a really nice abstraction on top of it. So for me, that's sort of the sweet spot for development. Certainly all our team thinks so. How do I get started? So if you've got .NET Core installed today, you already have F#. It's already installed by default as part of .NET Core. So you can literally do .NET Core, .NET new console --lang F# and you're good to go. Visual Studio, great support, code, Rider. Rider has some really nice refactorings that it's adding in now, so definitely worth looking at. How do I get started if you've got an existing app? Well, I tend to think of it as probably a few different ways, what I call logic islands. So if you've got an app and you just want to add on a small bit into F#, take, a small module or maybe a couple of classes and say, let's do that as a module with some, some business logic. Takes in some data, gives back something else. That's one way. Second way would be a vertical slice. Try and go end to end as much as you can from the database all the way up to the client in F#, but only for a small module of the app. Or a horizontal tier. So maybe your data access or your testing libraries or your caching layer. One of those things could be done in F#, something like that, that will go across all the different layers. You can call F# arbitrarily from C# and vice versa. So you can definitely do that. It looks like normal C#, like if you have a method or a let-bound function in F# in a module, it looks like a class with a method on it. You don't see any difference. I was chatting with one of our customers today, and this is one thing they said as well. If you do want to look at F#, don't do it on your own. Try and get at least one or two other people involved in it. Otherwise, you'll be left as that one person that is responsible for the F# code. So try and do it as a team. It makes it much easier to motivate one another and to actually do it on a regular basis. Even just an hour a week, book it for like, a lunchtime every Wednesday. You'd be surprised how quickly you can make progress on that. How do you learn? Obviously, there are companies like ourselves that do coaching and training. Plenty of F# developers out there, although you may not know it, but when we go to recruiters, we're able to get pretty quickly or through Twitter. There are a few F# books out there that you could look at, meetups like this one. The best way though to learn F#, do some F#. If the next time you want to do a hobby app, I want to try some code out, do it in F#. If you've got a module that you know well in C# or whatever language you're working in today, try and port it into F# because you know the domain already. And then it's simply a matter of doing how would I represent this in F# rather than doing two things at once. But doing it regularly, definitely important. I'll just show you a few website links and then I'll be done. So, just a small plug. So that's our company website, compositionalit.com. We have a blog we do at least once a week, if not more, with sort of examples and then sort of scenarios and things. So definitely worth looking at there. There's the F# forums on forums.fsharp.org. There's also the SAFE website, where you can learn more about the type of web app I just showed you. There's an example. There's also a dojo exercise. It takes like an hour and a half or so to do. Set up to go from scratch, so you can give that a go. Twitter F#, always lots of people on there, and Slack forums. If you want to learn F#, there's a huge number of people that are always on there, always happy to help. All the channels are full. You'll always get help on them, so I'd recommend that. Book I already talked about, so I don't have to talk about that. I already sort of touched on this as well. We've in fact done a whole series on this on our website. So if you are interested in sort of how do I get F# in my company, let's see if I can find it. That's one, but here we go. So we've got a series called How to Become an F# Adopter. It's 3 parts and just sort of explain some good tips and tricks for you, ways that you can explain. And so basically though, think about who your target is. If you're talking to management, don't talk about immutable data or type inference. If you're talking to developers, don't talk about high productivity and it's going to make us money. Well, developers should be thinking about that, but they might be more interested in other things. So yeah, already touched on this. Yeah, that's pretty much it. So I think we've got probably a few minutes left if you want to do any QA. Don't ask what a monad is. You're going to be disappointed with the answer. But otherwise, yeah, let's have a look at the Q&A then.